Okay, so let's actually take a look at another property of indices. So if we have something like k exponent 1 over maybe y. So if you have something like k exponent 1 over y, according to indices, this is the same as, so we read this as the white rule of the white root of k, okay? The white root of k. That is, I mean white, I mean like this, YTH root of k. So a typical example we can take of this is maybe 4 exponent 1 over 2. So 4 exponent 1 over 2 is the same as, and we read this as the squared root of 4. That's how we read this. But you know, there are some conventions in mathematics. For example, if you have maybe something like 1x plus 4x equal, let's say 10. If you have something like 1x plus 4x equal 10, we usually say that you shouldn't write this one, right? So if you don't see any 1 attached or as a coefficient to this x, you should know that there's a 1 there. So that's why you're able to add a 1 to the 4 here to get 5, right? That's good. Also, we also say that any number standing alone has an exponent of 1. So the fact that you don't see an exponent there doesn't mean there's no exponent, but you should know that the exponent should be 1. So similarly, when we want to relate this understanding to the square root of 4, in most cases, we wouldn't write this 2. We would rather write it as this. But then, although the 2 is not there, you should know that there's a 2. That's why we call it the square root of 4. So the answer for this is actually equal to what? 2, right? Root 2. So another way we could have easily solved this to get the 2 will be, another way we could have easily solved to get this 2 will be, we can raise 4 to base 2. That's going to be 2 exponent 2, because 2 exponent 2 means 2 times 2, and 2 times 2 is equal to 4, right? So we can raise 4 to base 2, and after raising 4 to base 2, we subject it to the exponents we have here. So this 2 is going to actually take care of this 2. We are going to get 2 exponents 1 times 1 over 1. 1 times 1 is 1, 1 over 1 is 1. We are going to get 2 exponents 1, which is equal to 2. And that's the same as this 2 we have here. So there's another way that we could have easily solved this. So whenever you hear squared root, it simply means the number exponents half. We also have the third root, okay? So the third root, you can write it like this. So we always say that the third root of 8 is equal to 2. And the reason why the third root of 8 is equal to 2 is because third root from here simply means 8 exponents 1 over 3. Okay? 8 exponents 1 over 3. Now, 8 can also be written as 2 exponents 3. Okay, so 2 exponent 3, then 1 over 3. So this 3 can take care of this 3. So you are going to get 2 exponents 1 times 1 over 1, which is equal to 2. So these are a few conventions we also have to actually understand in order to make our study of indices very interesting. Let's look at one last example on this. So what if we have something like maybe b exponent a over c? b exponent a over c. How are we going to write this in the root form? So if we want to write this in the root form, this is the same as b exponent a exponent 1 over c. So b exponent a, then exponent 1 over c. And we know from here that we can rewrite this as the sixth root of what? B exponent a. So this from here is the same as this over here. Okay? So let's take a typical example. We can have something like maybe 27 exponent maybe 2 over 3. So 27 exponent 2 over 3. So this is going to be the same as the third root of 27 squared. Okay, the third root of 27 squared. And if we want to solve this, 27 is the same as 27 is equal to 3 times 3 times 3, right? 3 times 3 is 9. 9 times 3 is 27. This 3 has an exponent of 1. So let me bring it over here, since I'm moving away from my board. Since I'm moving away from my board, so let me bring it over. So 27 is the same as 3 times 3 times 3, okay? All the 3's have exponents of 1. From indices, we can just add the 1's, okay? That's going to give 3 exponent 3 equal to 27. Meaning 3 exponent 3 is the same as 27. So we can fix it over here. Then we'll easily solve the question. So this is going to be the same as 3 exponent 3 times 2 over 3. This will cancel that. So we simply get 2 exponent 3, which is equal to 9. What this means is that 27 exponents 2 over 3 is actually equal to 9. Okay, good. Let's look at one last property of indices. Then we'll start solving questions on this. Okay, so let's look at one last property of indices. So if we have something like a over b exponent negative, maybe negative c, a over b exponent negative c, indices says that this is the same as, you just reciprocate the fraction here, okay? So it's going to be b over a exponent c. So a over b exponent negative c is the same as b over a with the exponent of c, okay? Good. Let's prove this and see how come they actually had it to be this way. So from indices, we know that this should be the same as a exponent negative c. You can subtract each of the numbers here with the exponent, okay? So this is the same as a exponent negative c over b exponent negative c. And then over here, we know that this and that are divided, right? So since they are divided, it can be written as a exponent negative c divided by b exponent negative c. Okay, good. Now, one of the properties of indices we studied made us aware that a exponent negative c is the same as 1 over a exponent c divided by 1 over b exponent c. Okay, we've actually looked at this property. So we'll have to change this division sign to multiplication. But in changing this division sign to multiplication, then we reciprocate this. Okay, so reciprocation simply means that we will take the denominator to the numerator, then we take the numerator to the denominator. That's simply what we are going to do. So 1 over a exponent c times b exponent c over 1. So this times that, 1 times b exponent c is b exponent c, a exponent c times 1 is a exponent c. Now, according to indices, since this exponent is the same as this exponent, we can take it out to be an exponent for the whole fraction. So this is going to be b over a or exponent c. So we started solving from here, okay? And then we had this. So you can see that it is true that a over b exponent negative c, which is this, is actually equal to b over a exponent c, as proved from here. Okay, good. So this actually a proof for this. Let's start taking let's take some questions on this. Okay, so let's try something like, I'd like to clean the board so that I can create more space for our work, okay? So you can choose to pause the video over here and then you write. Okay, so let's take something like 16 exponent x minus 1 to be equal to 64. We want to solve this question. At least you have some knowledge about how to raise these bases. What we are going to do here actually is that we try to raise 64 to base 2. We write 64 in base 2. We also write 16 in base 2. Or in other words, we can say that we try to find a common base for both 64 and then 16 so that we can equate them. So 64, let's take 16 first. Let me write that down. 16 is the same as 2 times 2 times 2 times 2, right? 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. Good. So each of the two have exponents of 1, right? Good. So we'll just add them. So 1 plus 1 plus 1 plus 1 is 4, right? So it means 16 is the same as 2 exponent 4. Let's write for 64. So 64 is equal to 2 times 2 times 2 times 2 times 2 times 2, right? So 2 times 2 is 4, 2 times 2 is another 4, this 2 times 2 is 4, right? So 4 times 4 is 16, right? So what's the answer for 16 times 4? So 16 times 4 is actually 64. Good. So since we've seen that this is the case, each of these twos have exponents of 1. So we just add the ones over here. So 1 plus 1 plus 1, 1, 2, 3, 4, 5, 6. Meaning 64 is the same as 2 exponents 6, okay? So we are going to replace the 16 here by 2 exponents 4, replace the 64 by 2 exponents 6. That's exactly what we're about to do. So the 16, we write 2 exponent 4, then we repeat the exponents. The 64, write 2 exponent 6. Now, there's another thing in mathematics, as we talked about the left-hand side and the right-hand side. The equal to sign here means that whatever is here at the left-hand side is the same as whatever is here at the right-hand side. So since we are able to see that this base 2 is the same as the base 2, for this side to be equal to this, it means that the exponent should also be the same. And if the exponent should be the same, then it means we can equate the exponents, okay, to be equal to 6. Yes, so when we get here, what we'll just do is that we'll just expand the brackets because we want to find our value for x. So here is going to be 4x. 4 times 1 is negative 4. 4 times negative 1 is negative 4 to be equal to 6. Then later on, what we are going to do is that we are going to actually group like terms. So this 4 doesn't have any x, so we'll take it to the right hand side. So we are going to get 4x to be equal to 6. The 4 is negative over here. If it crosses to the right hand side, it becomes positive. Your sign at the left hand side changes when you move to the other hand side, okay? So here is going to be 6 plus 4. That's going to be 10. So we have 4x to be equal to 10. To be able to find our value for x, we just divide by 4. So x is going to be equal to 10 over 4. Is there any number that can divide 10, that can also divide 4? Yes, 2. So 2 can divide 10 5 times, and can divide 4 2 times. So the answer for x here is 5 over 2. If you want to write 5 over 2 in the decimal form, it's 2.5. Now, whenever you get any answer in mathematics,